Okay, so it's starting the stream. There we are. So I'll keep an eye on the user count as it's as they're joining us.
Great.
And I think if you've got an intro slide or something, you're welcome to put it up. Or maybe let's do this. Let's
I can't
have a chat. Let's have a chat so long. And you can, I think, quickly try screen share.
You're preventing me, I believe.
Oh, sorry. Permissions. Permissions. Sharing. Okay, you should be able to now.
Excellent. All right. You want me to begin?
Well, what I'm going to do is I'll do an intro in a little bit, so we can chat while we're waiting for people to come online.
Excellent.
Okay. So, thank you. Yeah. No, I'm quite excited to hear about Project Panama because I've actually been waiting for something that improves on J&I, because that was one of the things I did in on those very first projects. So there was one was front end to where so the company I worked for, we built a treasury system, and part of this was to provide our users with a now our users were basically personal bankers in the what did they call them? They had a nice euphemism, but for filthy rich people. And so these people would like, oh, I want to buy a house in on the French Riviera. Can you please send money from there to there? And then they have got to do a forex deal for them. And what we would so this we built a forex order management system, and but there would be a few thousand users to this, whereas the rest of the treasury system had a small user base. In other words, those were dealers and risk management and stuff, and it's probably about maybe between 30 and 100 in the organization. And but rolling out to a few thousand is a different game. So we decided, well, we're going to use the web. So we had an applet that allowed us to give quick updates to changes, and so they could basically see all their orders listed, and they can organize them or search by client or whatever. And oh, we've got a question. Not where does the question come from? Not where. It's always a challenge. We're on YouTube. We're streaming on YouTube. So yeah, so we had an applet. I basically used the slow pull to get updates. So it'll do a request, but the request would hang or basically wait for a certain time before it would respond if there was a change. because our system had a built-in pub sub. Now, to support the bridge from the Java system to the C++, we did some of the stuff in with JNI, and so yeah, jumped in the deep end there.
It's pretty painful, I'm sure.
And no, but what we did is we actually, so we had two key mechanisms in the system. The one was an interprocess communication system that we developed ourselves, because it started in 95 when Corba was still crawling. And we found a nice little tool that was actually supposed to be a UI code generator, but it had a built-in meta model that was actually extensible. And one of the guys found the switch to flip. So we could add our own meta models, and we could add our own code generation, and we generated the equivalent of what IDL to code would be. We generated with this thing. So we generated all the C++ that represented the client and the server and the messages and everything. So when Java came into the mix, I just generated the JNI and the Java client and everything alongside that. And we had a similar thing for our persistent model. So
wow.
I actually generated JNI to talk to our ORM. And then we did start building some stuff in Corba when we built the integration server so that it could talk to
Corvus
application. And because by then, so then we were looking at 99, and Corba was reasonable, but it couldn't do all the stuff that our thing could do, because our thing could talk back to the client, and it could broadcast, and it could do all kinds of stuff. So we decided to stick with it, but then we said, okay, for bringing data into the system, we'll provide some Corba endpoints. And oh, those were fun days. We didn't know stuff was supposed to be difficult. We just did it.
Yeah.
Oh, I see we have a few people on the chat so long. It looks like, and I see, yeah, it's 10 past, so I don't think we will get more. We usually have a few people who sneak in a bit later, but I think we can kick off. So everybody, welcome to Josie Jug. I hope that you're also enjoying the good weather we're having. I'd like to welcome Carl Dyer from Azul. It's an organization that I have huge respect for, because I honestly believe that if it wasn't for the work that they've been doing in about the last 20 years, the JVM wouldn't be as well suited to performing well on multiple processors and huge workloads and things like that. And because they've been pushing the boundaries and dragging Java forward at a time when it was stagnant, and now they're still part of the process that we'll have seen pick up steam in the last few years. But I'd like to introduce Carl, who's a developer advocate at Azul. And as his slide says, well, I want to know what Project Panama is all about. And I think you too. So I'm going to hand over to Carl, and I'm going to shut up. Thank you very much, Carl.
Thank you, Cornell. Hey, everybody. Thank you for coming to my talk. This is about Project Panama. What's it all about? I'm excited to tell you about the upcoming release of the general availability release of JDK 19. It's probably in the September timeframe. That contains just some of the features of Project Panama. There's more features, of course, which I'll get into later. It's really cool because it's a really powerful API that allows you to access native code in pure Java. So the intent of this talk is to help you guys and gals just start using Project Panama. This is a really basic introduction. My name is Carl D. again. I'm a developer advocate at Azul Systems, where we build high-performance Java runtimes to help companies reduce infrastructure costs. This is a quick plug. We have 2 JVMs to choose from: Azul Platform Core, or Zulu. This is the free version or community edition with option of paid support. And then we have the Platform Prime, which is our commercial version that has the optimized features such as quick restart. It's called Ready Now. We have the Falcon JIT compiler. It uses like LLVM. It's just a better JIT compiler. We also have CNC, which is a cloud distributed JIT compiler for constrained devices, and also just a better way of distributing JIT compilation over cloud resources. And we have the famous pauseless garbage collector called C4. So head on over to azul.com and click on the download and give them a try. So let's talk about Java and native access, and this is the current state of it today. So did you ever know that the game Minecraft was written in Java? You're probably wondering, how does Minecraft achieve high frame rates? Or how does it render 3D objects so smoothly? Well, it uses this library called LWJGL, which is the lightweight Java gaming library. So you're probably thinking, well, what's inside that actually makes it all possible? How does it, perform so well? Of course, the title says JNI, which, of course, but as a Java developer, you typically need access to things like OpenGL or SDL libraries if you want to access the hardware like graphics cards or GPUs. Or you may want to talk to an RFID card reader at a low level. You can write it in C and you can access it, and you would use, JNI, of course. But let's face it, JNI is really, really difficult to work with, and it can be a pain in the butt. So let me explain. So I typically try to explain this. It's really difficult using JNI from 2 perspectives. First is the implementer of the API. This is when you start developing APIs for the user of the API. Those folks are actually using your APIs that you develop, and the user is just purely using it. So just to give you an idea, the implementer of the API, this is what they typically go through. So let's look at a quick primer on JNI. So JNI, it consists of your Java program, which is purely interfaces using the native keyword, and the actual implementation would then be the wrapper code. But here, you first compile it, and you could use a tool java-h-jni off of the compiled class files, which will generate your header file. And then the new way, I think it's either Java 9 or Java 10, they created a switch called -h. So you can do it in one step by compiling your interface program in Java, and then the dot, it's the current directory. You're just specifying what directory that the header file will be generated in. And so you're targeting that mylib.java, and that contains the interface. And then what it'll do is create the mylib.h, and with all the naming convention and the mangling, and it provides you the J9 environment struct. It allows you to work in both worlds, either Java or the C world. And then lastly, well, this is not the last, but here you create the actual implementation that talks to the native libraries. So here you would include your generated mylib.h, the header that was generated from the previous step, and then jni.h and standard input output or standard io.h to do more in the program. So here, depending on your compiler or your platform, in Windows, it's a DLL file. And with Macintosh, it's or Mac OS, it's dilib, and the extension of Linux is .so files. So once you generate and compile these libraries, you would use the system.load library to load these libraries from the platform. So here you notice there's at least 5 steps, which is really painful and can ultimately be difficult to manage over time. If you change an interface, you have to regenerate all these header files. And so now from the perspective of a user of the API, I just want to tell you a little story about my past job experiences when working with JNI. So back a long time ago, I used to work on a project that was a server project that was pure Java in the beginning. And we needed, one of the use cases was to be able to talk to Outlook, Microsoft Outlook, and schedule an event or some sort of task within the Outlook calendar. So our team came across this library. We're just users of the API, so they actually were the implementers of the API. So they had to create the header files and such. And so here you have a guy named Dan Adler. He built this project called the Jacob project, and it's a Java COM bridge. And in the Windows world, they're called COM objects or ActiveX controls, which allows you to interact with the Windows platform natively. So as a user of the API, you would build your application, your business logic in this layer. Then this actually talks to the Jacob library, the jar file, which actually contains the interfaces and maybe some implementation that actually talks to the wrapper code that is generated and compiled for that platform, the Jacob library itself. And then the Jacob library, which is written in C, that ultimately talks to the native libraries that are on the platform. But wouldn't it be nice if you could just talk directly from your business logic right to the native code, bypassing those levels of indirection? And so that's where Project Panama comes to the rescue. So new in Java 19, I'll explain this in a minute, but it's a preview release of Project Panama. This is just an Office Space reference. So what is exactly Project Panama? Project Panama is a bunch of guys and gals over at Oracle and the community, that a lot of PhDs and a lot of discussions going back at least 6 years, discussing all these Java enhancement proposals, or JEPs, to solve a lot of various requirements for accessing native hardware, and also understanding memory access. So it's really an umbrella project. So Project Panama, when someone asks you what is Project Panama, it's really just an umbrella project comprising of all these JEPs. So all these JEPs from left to right. From the left, you have the vector API. So you have incubators. At some point, they're going to have their preview release. So this talk is not going to be about that aspect of the vector API. Maybe in the future, I will do some tutorials and such on that. But as it started with the foreign linker API, and then they found out that there's foundational things that really made sense when dealing with memory. So the far bottom right is the foreign memory access APIs that had developed over time. And also, so the, I guess, a sub umbrella, the upper right is what this talk is about. It's about JEP 424, which is the preview release coming out from JEP 419, which was this second incubator. So here's a quick roadmap and a timeline of the events since 2018. Of course, it does go back a little bit further back. However, these are when the JEPs actually got, the proposals were, discussed and actually being implemented as proof of concepts and such. So in 2021, you have your first and second incubator, JEP 412 and 419, and then earlier this year of 2022, you have JEP 424. So a lot of the APIs kind of changed, a lot of bug fixes, and that's where we have JEP 424. And coming in September, when probably the general availability release, you still have to enable the preview switch on the Java command prompt. So to unlock these features. So it's just mainly JEP 424. Like the vector API is not in preview release, so you can only use the incubator ones. So you'd have to include those as modules if you want to use the vector API. I think it's the fourth incubator, but I just wanted to give a quick note about some of the discussions that are going on. We'll learn about memory segment and memory address classes. They're going to combine them. So that would probably be in Java 20, because there's some aspects of like how you look at native memory is very similar in context of like when you're dealing with spatial bounds, there's actually a pointer. So in that way, it's looked at from the memory segment class. But when you're looking at a raw pointer, it's just this address in memory pointing to, even null or anything. It's called the memory address. They're thinking about, or not thinking about, they're going to combine them in favor of the memory segment and remove the memory address class. But that will still remain probably in 20. It's hard to tell, but it may be changed in 21. So it's hard to say. So what are the benefits of Project Panama? So what's great is it's a pure Java solution. You don't have to write any C wrapper code. You don't have to do any of that anymore, like JNI. It's fast. It's as fast or faster than JNI because you don't have to deal with the layers of indirection, calling those layers. And this is another great feature. It's when you get a binary build of your JDK, a JDK 19 or for your platform, say Intel or ARM 64 or whatever operating system, like Raspberry Pi or something. Various memory architectures are different, so they can have different byte widths. So like it could be 32-bit or 64-bit. So when you get the build for your platform, it will know the byte order. If it's the endianness, it's big endian or little endian. So here's another thing that's really great. Unsafe operations are disabled by default, and you would actually, when you're running your program, you can actually add a switch that will activate it so that you're, allowing your application to access things using the unsafe operations. You're talking to native libraries. So how does Project Panama actually, talk to native libraries? Currently, Project Panama only supports what is called the C ABI or C's Application Binary Interface. It's a well-known convention. C's been around forever, and these conventions are very well known. For instance, TensorFlow is written in C. There's a library written in C, but a lot of the tutorials are written in Python, but they actually talk to the C ABI. And so when they create Python objects or whatever, or primitives, and they're passing them into the C function, it's seamless to the Python developer. It's literally talking to a C library. And so OpenJDK with Project Panama or foreign function APIs allows you to talk to native code or native C functions. So another thing that's great, if you understand the convention of the C ABI, it allows you can write Java code like static functions, or I think there's another way, even if it's an instance method, you can actually pass that function into the native library. And that native library, since it understands the C ABI, it's able to invoke your function even it was written in Java. So here are some advanced demos that isn't the fun. I'm going to show you how to do the fundamentals later. However, before, when I started this journey and learning about Project Panama, I was using the JExtract tool before it was included with the development branch, but now they removed it. It's a separate project. So I used JExtract to actually generate some of the binding code, the Panama code, that it saves you a lot of time instead of actually doing it fundamentally, like how to create a method handle. So here's a demo of using Project Panama to talk to the SDL library, which creates a native window on your platform. So you can create a native window on a Mac, on a Windows, or Linux. So a lot of gaming companies, they'll use SDL to create a window natively or receive sound and such. And also the OpenGL library was used also. So I was able to create things like the cube that rotated, and it's very performant. It's, it doesn't use any of the resources on the Java side in terms of like using the native hardware, like the GPU, to compute vector math. So just a quick glimpse of the code. A lot of people who are familiar with OpenGL, they'll notice this code right away. But right here, it's just purely Java code. You're creating an array. So this is basically it's called a pixel shader. It consists of the color, the gradient that you want, and then there's something called a vertex shader, which is where the positions of the vector are in relation to the cube face when it creates like, a triangle, or when it assembles the cube. So here, we'll talk later about what a memory session is, where you can allocate an array, and it actually creates a native array, and it can actually create it off heap, not on the Java's memory heap. So this shared memory area, or this region of memory, is going to be passed to the GPU and actually doing the computation very rapidly in parallel. So if you notice here at the bottom, there's a method called cube edge, which I created. The GL color 3 FV, that function is generated by JExtract. So JExtract generates all these really convenient methods, and it looks identical, well, almost identical to your C counterpart, like if you're writing it in native OpenGL. So like, for instance, this looks pretty much like your C code, except for like static or constants, like the GL_no error. Of course, when JExtract created it, it was a method, and it returned the int. So you see the parens on the end of the GL_no_ error. And that particular thing, but other than that, it's like, it makes you feel right at home. If you're familiar with OpenGL code, it looks just like this. So converting your old code into Java, so you can, provide logic, and then passing it to the, OpenGL library to do all the hard, heavy lifting. So here's how you render the cube. It's same code. it's so all these convenience methods like GL clear color, GL clear, those are generated by JExtract. So here's another great library called ffmpeg, which is really cool. You could actually stream like audio and video. So you could actually take, like, one use case would be great is like, if say you created a security camera and you take IP video streams, and you could actually pipe it into various windows, and you could display them. And so here's an example. I'm using a JavaFX application. I'm using the scene graph, the canvas. I'm sorry, in the scene graph, I'm literally piping the video stream into the scene graph area, and then overlaid, I have a transparent canvas node that draws on top, and I move the mouse, and I create a call out library that makes a really cool effect. Anything of interest, it will, do this fancy call out. So now that you've seen the power of Project Panama in talking to native libraries, we're just going to do something very simple, like a hello world example. So to get started, you can go over to our site, or you can go over and just download your JDK 19 early access. So once it comes in GA, other places will have it downloaded. So some people don't have the EA. So, or you can go to fuj.io. That's where I blog a lot about other things, but there's a slash downloads. Yeah, over at real quick, over at azul.com/ it's downloads with an S, and then over at fuj.io, it's download, it's singular. But here you can, with this really great API provided by my colleague, Garrett Grunwald, you can pull down any distribution from any vendor on the left there. So try to get JDK 19. And if you want cutting edge, you get the latest and greatest from the release builds or the development branch builds that come out often. Sometimes they come, sometimes once every 2 weeks or something. So check that out. jdk.java.net/19. I think there's already also a jdk.java.net/20. So, but anyway, go over there. You can download whichever architecture you have. So really simple. You set up your Java home environment variables, whatever platform, Windows or Linux or Mac, or you can just bypass that stuff and not deal with it. And you can use JDK Man, which you can download using their tool. So just a quick check. You just say Java-version, and you just want to make sure you have the right, you have JDK 19 EA or the GA that comes out in September, probably. So before we go into Project Panama and how to use it, let's look at what native Hello World in C looks like. Just to give you an idea, because the more you understand the language that you're targeting, the better you can actually use the foreign function access APIs. It's really important. So they first start out, this is just a simple hello world in C. You first start out with an include. It's very similar like Java's imports. There's a platform or standard library called standard IO, which is input output header. And they have a main just like Java, but it returns an int instead of being void. So there's a native function within standard IO called printf, just like system.out.printf. Like it's modeled after this function actually in Java. So instead of print line, the printf function or method in Java is from this actual function in C. So of course, just looking at the signature, it returns an int. The printf returns an int, and it has a pointer to a character array in C. And then at the end, you'll see variable type arguments, or they call it varidic arguments. So in the main, it returns an int, and typically anything on the Linux platform or the Unix platform, they use 0 for meaning everything is okay, and anything else is an error or status code. So just, it's neat because you could pipe things in on the command line. And so they standardize that as, using 0, meaning it's cool or okay. So let's see. So let's start using Project Panama and try to mimic that exact thing we did in the prior step, which was using the foreign function access APIs to talk to the printf function. So there are 3 steps in actually calling a native function. The first one is creating a memory session where you use the try resource block, and I'll explain that in a minute. It's from the memory session class. And then you actually have to obtain the linker, the native linker. It's a concept within the C world. It's similar, where you can from the linker, you can actually obtain symbols in memory, and then using the down call handle, it actually creates an object called a method handle that references that native symbol, which we'll talk about. And then last step is taking that method handle and then invoking it. There's another method. The invoke is your typical one, and then there's another one called invoke exact, which we'll talk about in a minute. So to create a memory session, you simply, from the memory session class, there's an open confined method. So within your method, you'll create this try resource block. And so that memory session object that is returned, of course, anything using the try resource block implies that it implements the closable method or the interface. So that method, when you come out of scope, that end curly brace, it would close appropriately. So it would clean up memory in the native world. So if you're creating memory, you're doing native stuff within this session or scope, it will clean up if you're using the same memory allocation methods. But it's really cool because you don't have to do a lot of the native ways to deallocate memory or clean up memory. So a lot of this is, it's really nice and convenient. So you can play in both worlds, Java world and the C native world, and your objects are collected. It's kind of cool. So here are other methods, overloaded methods, or other methods that allow you to define your memory session. One is called open implicit, which you can do that at random times if you need, a session very quickly, like you just want to create a string and you don't want to have to use the try resource block. It's just so much typing. But then for the open shared, there's different like threading contexts, and you might want to share that memory session across boundaries. But this talk is not that advanced, and we're not going to use open shared. And then there's also ones that accept a cleaner. It allows you to clean up if there's additional steps that you want to have happen, such as, some things you may want to clean up that are difficult to clean up in the C world. Maybe files, handlers, or processes you want to kill, and things like that. So you can use those functions. So second step, really cool, really important. You want to create a method handle by using that linker's down call factory function or method. So really quickly, I just wanted to give you, in layman's terms, an easy understanding of what a method handle actually is. It's just simple. It's just an object, a Java object that references a native function or a C variable. So if something is created in the native world, you just want to have access to it. It has to be loaded. So in order to load it, there's even in the JNI world, there's the java.library.path property variable or property that you can specify where libraries are actually located. So java.library.path, if you could specify it on the command prompt, it can look for your third-party library. But the platform libraries are already loaded, so you can have access to those. So when you create a method, handle, it's very important to understand a native function's signatures. For instance, what's its return type, and what are the inbound parameters, and even the name of the function. Because in C, there isn't object or method or function overloading. There's not a function overriding. That they have to be, there's only one. So when you get your Java runtime or your JDK, it comes with predefined what is called value layouts, and we'll go into that in a minute. But it's what a value layout is it describes a native value represented in memory. So for instance, the Java_int, it's of int, of the value layouts, which will go into the UML class hierarchy, and why this is important, because when you instantiate an of int type, it has that, notice that class, it says byte order dot native order with bit alignment. So whatever the architecture is underneath the covers, it will provide the right way to store that int value. So it's 32 bits, but is it, least significant bits or most significant bits swapped? It depends on the endianness of different architectures. If you're on like an Intel versus a Motorola chip, they're very different native ordering or byte orders. So when you get the JDK with Project Panama, there's these predefined Java_ints, Java_floats, and they're already predefined and you can use them. So it's like a cross-platform way to represent what an int is on both worlds, in the C native world and in the Java world. So when you want to create a primitive, or you want to describe, like in the printf, it returns an int, a C primitive int. You want, when you start to describe that signature, creating a method handle, you need to just grab one of these predefined guys that describe that method, and which we'll talk about in a minute. It's called function descriptors. But here you're importing them statically. You're just pulling the ones you need to describe that method handle. So you've already described the return type. You want to use the predefined Java_int. Now you know what the function or the symbol name is. It's called printf. It's just a string. And then another predefined value layout is called address, all in caps. That defines just a pointer in memory. So in this case, the inbound parameter, the first argument of the printf, is a const char, asterisk format, which is really a pointer to a C string. And a C string is an array of characters with a null termination. And I won't go into that, but in the native world, that's where C strings are not the same as Java strings. So they're represented as if it's an array. It's an array of characters. So on the end, it's similar to Java, where you have variable type arguments that you can specify to substitute values in the string. So if you use %s, it's for a string, or %d for I believe it's decimal or digit or something like that. You can pass in numbers. So here's the UML class hierarchy that I wanted to mention earlier. They ultimately all extend from memory layout. So memory layout is a way to describe how things ought to look in memory. Value layouts are the primitive types, and you have all these of, byte, of, short that represent the things, natively or the primitive type data. So the predefined ones I mentioned earlier, the Java underscore like int and short and char and float and double and address, they're available. When you download the JDK, you get them. And on the right, I don't know why I don't mention it, but we're still talking about creating a method handle. And this is where we talk about the function descriptor. We're describing the printf function and its return type and its inbound parameters. And so if you ran JExtract, you would get these value types. They're more specific to the platform. If you want to be more portable, you could use the Java ones on the left, and on the right, depending if you're targeting a particular platform, it might be better to use these. It all depends. So I typically, if I generate JExtract code, I will use the ones that it generates. So here's the value layout class, just to let you know. It's in the Java doc, java.lang.foreign. You'll see all the predefined ones that you can use. There's other ones that aren't the standard that you would see, because trying to represent certain bit widths on the native platform, there's like doubles, and there's a lot of strange, there's additional ones that might exist for your platform. So here it is again. You'll see the various, these are the predefined ones that are more portable, that you would, you're more likely, or it's safer to use. And yeah, I showed you this JExtract. So when JExtract generates these, it's actually generated Java source code or class files that have these things that are very specific to the platform. While they do have the layouts equivalents, they're probably mapped to the same thing, how it's defined for the Java underscore primitives or value layouts. They're generated during the time when you run JExtract. So now that we know how to describe various things like the return type, which is a Java underscore int, and then the first parameter, which is an address using that value layout, let's create a method handle. Like I said before, we use the linker, we obtain the linker, and then what we'll do is we call this, we'll call the down call handle method. But for right now, I thought this was really convenient to know. From the linker, there's a default lookup method. and that is an area where all the standard standard io.h, all those functions, anything that's native to the platform and standard is in the default lookup area. So the symbol name is just the printf function. You pass that in, it returns an optional object so that it could be empty. So this is just a convenience method you could reuse if you want. And so you could use the or if it's null, or I'm sorry, if it's empty. If the optional object is empty, it'll look in another area. And in the symbol lookup, loader lookup, that's the third-party libraries that you set in the previous, or what I explained before. The java.library path is where you specify the third-party library or something that you created that you want to load in Java. So it'll find it and that library and that function within memory. Or if it doesn't find it, it'll throw an exception. So finally, the main function called downcall handle, it takes that symbol, which is a memory segment. I just wanted to show you this real quick. So the return type is called a memory segment. We won't really go too deep, but a memory segment, again, is a pointer with spatial bounds. So it represents the function in memory. And so once, assuming you're loading it, okay, so from the linker, there's a method called downcall handle. So you pass that thing in memory or that pointer as the first argument, the symbol. And then the second argument is what we talked about earlier was function descriptor.of. And that that method returns you your method handle. So here you have you're describing Java_int, and that is the return type. And so there's another method called void, which implies that the return type is void, and then you're just passing in address. So you could call that if you don't want to use the return type in your function. So hold on. I'm sorry. I have to. Okay. So the last step, really simple. Again, there's this thing called a memory segment. Using the memory session that we defined earlier in the try resource block, we then use methods on it. It has allocate UTF-8 string. This is how you create a native C string, and it puts it in memory. And a reference to it is we just created a variable C string. And then what we want to do is invoke it, and just so you're talking this natively in the way that it wants to see it. So you're not passing in a Java string, you're passing in an actual C string into the method handle, and it outputs hello world. So there's also another one called invoke exact, which is more, it's you have to cast things. It's very strict in the way that it needs it. So for instance, the string that you pass in, the C string, you have to cast it to addressable, and the return type, it requires an int, and then you have to cast it. So yeah, so if you use the invoke, you got to be careful, because you could have a cast class exception. So what about the variable type arguments that are passed in to the printf in the native way? because what we defined a method handle exactly. We described it with the return type as an int and the inbound parameter as an address or a pointer to the C string. That's only two things that we described with the function descriptor, but that's you can only call that function that way. You cannot start adding things like this, like for instance, I'm passing in a string universe, and I'm passing in an integer 42 into this other string. So that's really three arguments, or you're using a function descriptor to describe three things, not one thing like we did prior. So how do we actually invoke something like this? So there's a convenience method called append argument layouts, and as Veridic method, which allows you to specify things on the end, just like it needs to. Like for instance, the printf, it requires like two things to be passed in addition to the return type. So it's 4 items you have to pass in. I'm sorry. So in the function descriptor .of, the first argument is the Java int, which is the return type of the printf function, and then the 2 additional methods. Then you pass in the description of the arguments being passed in. So the first one is the string containing the template or life, comma, the %s, and everything is %d. And then the second string is universe, and then the Java _int is that 42 that will be passed in. So this is how you do it for strings. I showed you earlier the memory session. There's a function that will create a C string in memory. And so here you have, it extends from addressable. So I kind of did it more abstract. So argument 1, 2, and 3, you can invoke that method handle by specifying it like that. Now, the problem is here, when you call the down call handle method many times, it's not performant. So usually, just like the way JExtract does it, once it defines these methods, it will create them like public, static, and final. And so like the JVM can actually optimize it and JIT compile that or inline things. So this isn't very performance. This is just an example to show you how you would define a method handle. So I explained again, like I said before about JExtract, is there a better way? Because it's kind of annoying having to describe the method signature. So with JExtract, boom, when you target a header file, and then it'll generate all these convenience functions for you. So you don't have to deal with a specific signature. You can start tacking on n number of arguments on the end and your string template, and you can just code it like you would in the native world. So you can translate your native code into the Java world pretty easily, and it's easy to read. So really quick, jdk.java.net/JExtract is where you can download JExtract for JDK 19. So you'd have to set your path there so that you can actually run that tool against any like say OpenGL libraries or SDL, or so if you point it to an header, you can actually generate all these pure Java code for that platform. So I showed you how to talk to functions, and I briefly talked about memory segments and value layouts. But here's just a glimpse of how to create simple primitives. So we talked about memory layouts. So what is a memory layout? So a memory layout can be used to describe the contents of a memory segment. That's basically what's inside of JDK 19 Java docs. So I showed you the predefined ones that are generated for your platform, the Java underscore, whatever. So here, this is just what memory looks like, sometimes off of the Java's memory heap. Here you have hello world Project Panama. So it's a string of characters, and it's just a blob of memory. And there's on the left, there's an offset. So 0 offset is the start of this string, the C string. So here's another, say for whatever reason it's deallocated, but it's still sitting there in memory, and you decide to create 2 longs, and one long contains the decimal 10 and the other one contains the decimal 2. So occupying 8 bytes on the first section there is one long value, or C long, and the other one on the other side, and then whatever was remaining in that memory area. So how do you create it? So we did talk about this earlier, about these predefined value layouts that they generate for you, but we need these so that the memory session can actually create these for us. And what they create is what is called memory segment objects. They're really just representative pointers. In the C world, there's a concept of pointers. It's really just an address in memory, or a place to hold it. It has an address, it has a storage area, and that storage area holds an address of some other value. So for instance, here you're creating a C double, and you're storing Java's math.py. And so inside in memory, there's a pointer. You don't have to see it that way, but it's just a chunk of memory, and it holds 8 bytes, just like in that description that we showed earlier. And so here you're creating a string, and it always returns a memory segment object. So for instance, next we're going to talk about how to actually access that chunk of memory. This is really important. Off of the memory segment, there's a method called get, and within get you have to specify the value layout, and then the offset, because you can actually, just like in C, there's something called pointer arithmetic, or you can walk an array, or you can walk pointers in memory. So in this way, it's more very direct. You're telling it where to start, and basically the size or the value layout, and how to actually take those bits and put them in the way that it needs to see them in Java. So it could be a different byte order and such, but this does this with this call. So when you return it, it was specified as pi. And so that Java variable X contains the value pi. And here is how you print. We showed you earlier about how to print F, or here we're using it in Java. We're just specifying, we're converting it back into a Java string. So here's how you take a memory segment that was a C string, and we're turning it back into a Java string so that we can output it in the Java world. So there's the output. So I don't know why I didn't show you before, but here is from the memory segment object. There's a method called set. This is how you set the value in memory. We're just taking the previous value in the Java world and we're just doubling it. It's 2 pi. And then we're setting it. You have to specify that second argument, which is the offset. Again, it's really important. You have to set that. So here you get the value. It goes into the temp double variable and you print it out and it's doubled. So you're actually accessing that thing, that memory that could be off of the Java's memory heap. So it's kind of cool. You're literally talking to native memory and safely. So here, I just wanted to show you that when you use JExtract, you could use its value layouts that it generates. So they're pretty much equivalent. It's safer to use, if you're using like, native, say it's on a Raspberry Pi or something, or an older device. A C int may not be 64 bits. It might be 32 bits. So sometimes if you're targeting a platform, it's nicer to use whatever you use JExtract against. So there's a fflush function, and what represents a null, you pass that in and it'll output. Because if you're using printf in the C world and in the Java world, it's printf, that they're on different, they're just different. So it doesn't behave the way you think it would in the order in which it prints it to the console. So it's really important to kind of like, you're literally telling the buffer to flush on the native world so that it would output to the console. Because if you say printf under, say you didn't do the fflush and you did a Java printf underneath the native printf, the Java one will, the ordering, it will print first. So it also could depend on the platform too. So this is more control. So how do you run it? So we're really close to the end here. On the command line, you would specify the enable native access. Like we said before, we're opting in for all the modules. And then the enable preview, and then you have to specify the source if you're running. In this case, what I'm doing is in Java 10, I believe, you can run a relatively small Java file. If it's just a single file like hello world.java, you don't have to compile it. You could just run it straight up, and you'd have to specify dash source 19 though. But yes, if you compile it, you don't need the source 19, but you still have to say enable preview for JDK 19. So once it comes out in GA, oh, well, I'm sorry. Yeah, Java 19, it's still considered preview release, which is JEP 424. So I already explained that, and there's your output. So there's much more to talk about. We're probably running out of time. I just wanted to point this out. It's really cool. We did mention about C pointers when it relates to C strings that are arrays, but there's also other things that you could do, like pointers to structs and pointers to, even primitive types. So sometimes when you're targeting native functions, some of the functions are really crazy looking. If you're not using JExtract, say you're targeting it, some native functions have handles, and that's the concept of a pointer to a pointer. So sometimes you have to understand pointers to actually call them appropriately, or it'll crash. So there's structs, there's pointers, there's structs, how to allocate arrays. You can do array of structs, array of primitive values. And then there's the really cool ability to create callbacks, which allows you to create Java functions or Java methods and pass them into the library, and the library will invoke that for you by passing in parameters, triggering responses. So that's really cool. And then, of course, another topic is called accessing foreign languages. So that currently, because it only supports the C ABI, because it's a well-known convention and C has been around, I'm not sure if there's talk about C++ or other languages, but you could still all those languages, since they understand the C ABI, they allow you to expose them as C functions. So some of the advanced examples you can see, but I have blog entries at fuj.io. Just search for Panama and you will see a whole bunch of articles that I've written about talking to foreign languages like Swift or Python or C++ or Rust. So it's good to check out over there. I created a bunch of webinars at azul.com, and all the examples are here. There's more than just Hello World. I show you cool examples over at GitHub, my GitHub account. So check that out. So in summary, we talked about use cases of Java native access and using JNI and its pain points. And then we talked about the roadmap and its benefits and how it actually talks to native libraries, like using the C ABI. Then we had some demos and how to get started understanding the 3 steps to actually invoke a C function. And we did a little bit of memory, a little bit of understanding of how memory allocation works. So here are some references. Again, you can go over to some of the webinars. There's 3 webinars in a series, and you can go to the GitHub of this webinar or this tutorial, getting started, or what's it all about. And of course, go over to Fuji. It has all the examples from how to use JExtract and how to create memory, how to create structs and pointers. And so, yeah, head over to Fuji. So that's all I got. If anybody has any questions, feel free to, throw them out. Love to hear what people have to say.
I must say this looks nice because it seems like less of a jarring experience than using JNI, and it might even be a bit safer. So and yes, there's potential for it to be to perform better, because with JNI my experience was way back then, and I don't think much has changed, is that you're limited to very specific memory access, and everything that has to take care means there's lots of overhead that you that doesn't go away. But the beauty of the JVM is that they like, okay, we've called this thing this way X many times and nothing's broken, so we can strip out the safety checks and let's fly. And I mean, that's the kind of thing that can potentially happen, and it makes the whole thing a pleasant experience. So if you've got a library, you just import it and go for it. And then the biggest challenge is literally, where do you put this thing? Because everything else you can package neatly. So that's why I asked the question on the chat early, is I can't remember way back then, but is it possible nowadays to package your native code in the jar, or it might probably be the best is to have something that says, well, okay, it is packaged in the jar, and let's take it out and put it somewhere where it's going to be accessible. Because I assume that would use that. I think on the Unix-like operating systems, it's LD_library or LD_path or something like that, which is typically where it looks for dynamic link libraries, or the system libraries, or the equivalent.
Exactly, like user lib.
Mm-hmm.
And I think you in Macintosh, it's dy LD library path.
Mm-hmm.
So it's very similar. But yeah, I think it depends on how you want to deploy it. You know, like Java, there's so many different ways to deploy things. Because especially on Mac, there's security concerns. You know, they don't like even OpenGL, they're deprecating it, but they want people to use Metal API. So even when they had OpenGL, they wanted their version. They don't want you to install a different version, but then you would have to override it, and it was hard. But you want your Java application to run seamlessly and just take whatever's installed, and it doesn't have to fight with it. Like, you as the application developer, you know, it's bad that you have to find the right library and package it with your application. So that's
yes,
kind of
you
like
want to, yeah, I mean, you want to use the OS provided stuff.
Yeah.
And then I suppose that it would chuck up a warning if the API is somehow different from what it was when you did the development work.
Right.
So it probably checks that at load time, and because there's chances that you'll run into that they are different. And I can imagine if you've got a code that maybe that was done on for Linux and for Mac, chances are your ABI would be the same, and you go to Windows and then there might be something silly because the people who ported it ran into something about Windows, and then boom, you're in trouble. But now you can have a block of code that says, well, if I'm on Windows, I have to do these slightly different things, and you can still take care of them and deal with it, with those differences.
Yeah, I thought it was interesting also, like with JExtract, your build system, it's important to like know that JExtract can actually generate the binding code, the source code, for that platform. So you never want to check that code in that's generated, right?
Mm,
Um, so when you generate it, it's for that platform. So if you're jarring it up, you're going to have, like, just say there's only 3 operating systems, Windows, Mac, and Linux. You would have to let the build system build 3 different jar files because they're targeting, but it's still pure Java code, which is
mm,
amazing. So you
mm,
can
mm.
always, in your, in your POM file or Gradle, you can pull the one for that operating system or that platform. So
Mm,
if
mm.
JExtract generates the binding code, you don't want to check that source code in. You just want to, or you could just
Yeah,
generate the
the
class file.
resulting library, yeah. I mean, you'll have a
Yeah,
library with a different Maven classifier for
yeah,
each platform, and or find some way of dealing with the differences. But you can, if you, I mean, if you're packaging a desktop app, then obviously you go about it differently, and you use some of the nice tools in that space,
mhm,
and um, you'll actually have packages that target a specific platform, and that's the reality of shipping code that's native. Is you have that, or that has native components, is you have to deal with those differences. And that's why, even if it's IntelliJ, if you go to their website, you've got a Linux download and
Mac download.
a Mac and a Windows download, and it's because um, they have their own JDK build that they ship with it, and there might even be some native libraries. Remember, it was the same. It's the same with Eclipse, and anybody who wants to, like, maybe ship a game that uses um,
SWT.
that lightweight gaming library,
Oh, yes.
um,
Yeah.
they'll all be up against it. So they'll package something that's operating system friendly. The user doesn't have to deal with it. There's an install process that takes care of installing
Mhm.
the native components, and there you go. But it opens up doors to performance that's not insignificant.
Oh,
Because, I
yeah.
mean, you mentioned TensorFlow. Um, it's a powerful tool with a wide range of APIs, and um, if you use it from Java, you typically get better performance than the guys who use it from
Python.
Python,
Exactly.
because the consumer is a bit more performant. And I can see that, or I can just imagine that the team building this are exercising those types of use cases, because that's where it matters, because performance matters when it comes to machine learning and things like that. And I mean, the game that Azul is in is well, there's a cost of running your code, and if we can reduce that cost, then you can serve more customers with the same uh, um, amount of resources. And it becomes even more important if you consider um, most applications are actually, even if you build something, let's say it's cloud facing, and you you're typically targeting multiple businesses, not individual users. So to give them the best peace of mind, you want to tell them, well, your stuff's actually isolated. Now, that means that you have to stand up on infrastructure for that organization. And that means that you have to have infrastructure that fits inside what you charge them. And then it matters what the performance is like, and whether you can scale it up and down quickly, and if you can do a prediction on when they're going to be online, and you can scale to 0, and maybe the first response takes a few seconds because it took time to wake up, and thereafter it stays awake for however long. These types of things are important, and performance is never going to be a non-issue, especially if you're considering the cost.
Exactly.
There was a time when I worked for an organization who there was a bank, and that just meant that their cost model is just in a different place because they literally have too much money, and that they're not interested in saving resources. Now I look back at them, and I'm sorry for them, because they've made a series of choices that mean their architecture is so bloated and so heavy, and it's actually costing them a lot to scale and
maintain.
Oh yes, and they haven't been able to direct their attention to actually improving other qualities of the system. They've been trying to now tweak performance out of something that's fundamentally broken. And if you're there, then you're in deep trouble, and you're going to remain so until you rewrite things once again. And we spoke before we went live on air. I've got code that's been in production, Java code, for over 20 years without changing. And it just keeps getting faster because the JVM keeps getting faster, and the code is still working. And that's the beauty of Java. And I don't have any platform that gives you that, because if it was native code, it would have probably been targeting 32-bit back then. So they would have had to get to a point now where they have to explicitly install 32-bit support if they can get it. They might not be able to move away from the platform they are, where they are. And I think there was on all that code, we actually had one piece that was native, and that was our code that interacted with MSMQ, because it was an integration engine, and it actually supported MSMQ. But the original IBM MQ drivers, they still work. And that's remarkable.
Yeah, a lot of folks, they would ask me about that. About
you're breaking up badly at the moment. I think there's some of that audio glitch you were worrying about has come back. Because the video is actually fluid. It's now.
Is this better?
Oh yes.
Yes. Oh good. Yes. Wow. I hope was the video okay, or was
the video? No, during the presentation it was fine, but it was just now when it started breaking up, because you started by saying people ask me something, and then it went south.
Yeah, usually people will ask me like, what's the best way? Should we rewrite the whole thing, totally getting off of JNI, which is a good question, but it depends on a system. And I don't like saying depend, it depends, because that's like a cop out. But I mean,
well, you can say depends, and you can list it what it depends on. But I think what we realized quickly on is it's like when you're going to cross that barrier, you have to decide what's the cost. And it's the same with service calls. If you've got a chatty protocol, then you're going to be in trouble if you put these things on different machines or in different data centers, because your latency is just going to get multiplied by 1,000 every time. And I remember, this is about nearly 20 years ago, when I was at the same bank. I was looking after internet banking, and we were getting the performance great, and our user base was literally doubling every 6 months. And in the meantime, we were actually reducing hardware utilization below that growth. So we came off, I don't know if you remember the old Sun E25K machines, they're huge. We came off E25K onto 4 entry-level Intel servers.
Oh my goodness.
While our user base multiplied by 4. And we went onto those servers, and we still dropped the utilization at peak. But what was interesting is that you can keep pushing the envelope. But at the time, there's a team that came to me, and they were working in a different area, and they said, we've got a problem, we need help. I said, okay, let's take a look. And they said, well, it's this system that was done on Windows and .NET. And in fact, no, they were using, they'd originally developed it in COM. And then the bank said, we must have a 3-tier architecture. So you must have a web server and a business logic server and your database. So they said, okay, we were using COM, we can make DCOM calls to the business services, and they had the database. And the guy says, on my local machine, I can run 200 transactions per second, and on the server, I don't get to 30. I looked at everything and I said, you're using COM. Ah, okay. Look at this. You are instantiating something, and you're doing set, and invoke. And each of those are going across the network.
Yeah.
So all that did is they moved those two back together, and the performance was what they expected. But nobody was able to figure it out. But I came from outside, and I just asked these questions. And I said, okay, well, how chatty is this protocol? Because that can be that, because if the network utilization is low and the CPU utilization is low, and you've just got a queue building up on the web server, then there's some unexpected latency. And people don't think about the cost of making that line of code. And does it access local memory? Does it access a cache? Does it go over the network? Is it in the same machine? Is it in a different machine? Is it in a different data center? And you need to multiply those. And every time you do, then you realize, oh, wait a bit. This idea of thousands of microservices is not that good an idea. We have to be very careful when we do that, because it has to be something that does something meaningful, that lets you leave this process space. If you look at now, if you talk OpenGL, what are you doing? You're handing over a lot of work to OpenGL, and you say, go for it. And it goes for it. And even there, you're keeping the chattiness as low as possible. because it's the same even if you're writing that code in C, because that call goes into the GPU. So you expect to give the GPU work to do, and it does the work, and you find out when it's done.
Yes.
And ideally via a callback, because then you can do other stuff while it's busy. And yes, it's never as simple as we think. And but the tools for dealing with the complexity is just improving. And
Oh,
I
yeah.
love it. This looks like a nice step forward. And it simplifies the Java developers' work because you don't need a C compiler and all those things installed. You can now stick with a familiar tool set, and it's a matter of, okay, do I use JExtract, or do I use the
The fundamental.
the fundamental stuff, which will basically say, okay, I'm using the native platforms stuff, and I think a lot of it will depend on how big the work is,
Yeah.
how much you need to do.
Also, it's hard to, you almost have to know and understand the library that you're targeting, because that's in itself a very hard learning process. Just learning, like, what does this function do? There's so many of them, like just.
No, you can't. I wouldn't advise anybody tackle using a library via JNI that they don't understand. First, go and write some C code to understand this thing.
Yes.
Understand the pointer arithmetic and all the issues and everything, and then, okay, I know it, and now I can move up. Because I mean, luckily, when I did my first JNI stuff, I was also the author of the other side, so I knew that well, and I knew exactly how to approach this. And
with perspectives.
Yes, no, it's not the easiest thing to consume a library that's especially one that's not one of those that you had that nice slide of. So if it's something where, oh, here's a device and it has a library, oof. You're going to have some interesting days and nights. But it's the kind of thing that's still fun. I can imagine taking it for a spin on a Pi with some library that targets a specific device. It should be interesting to do, and because you can get away without needing all these other tools, but you still need to be able to understand C programming and C pointer arithmetic and all those things, especially if you're going to develop callbacks or manipulate structs and things like that. Then
I mean, if you could shield certain things like callbacks is kind of interesting, because if you can specify things that it needs, you don't have to, like, for instance, in callbacks, one of the hello world examples is sorting. Like in C standard, there's a sort method, passing the callback, and it's really calling a Java static method. There's no C code. It just knows how to invoke it, and it passes in the right information, C primitives. But there's one example that I have. There's a library called oh my goodness, I forgot the name. It's called I think it's port audio. So port audio allows you to deal with sound, and you can do all kinds of really great things with it. You can make it echo. You can you could create a mixer. It's kind of cool. You could take streams of different types of sound data and manipulate it. And so all the examples are online, and I basically translated it just like in Panama, and it looks like it exactly.
No, I think that's the lovely part, is that it won't be unfamiliar to somebody else. So if you're stuck on something, you can get that C programmer and take a look and oh no, but that's supposed to be something else. And
yes,
because
sometimes
these things invariably have 4 ints, and one is actually an enum that means this.
yes,
And you got them the wrong way around. And
exactly.
I mean, that's for us, that's the beauty of type safety, but in their world, it's
Yeah, so
a
in
different world.
Project Panama, there are safer ways to do exactly what you just described. With the memory layout, there's also something called var handles, and the way that you can create structs and you can create various memory layouts. Like you can create a custom layout. You don't need to use the ones that they have.
Yes, yes. No, it seems incredibly powerful. I can imagine that this is going to be a the guys like Hazelcast and all the caching implementations are going to improve because of this, and we're going to see some interesting things. So I think that the guys in the high frequency trading game and those types of they're just itching to get onto this, because I can imagine something in that space, because they sometimes manipulate FPGAs and things like that. And if you've got a nice way to talk to them where you can reduce the friction, and just, I mean, they're looking for nanoseconds, so and they'll get them, yeah. So it's lovely.
Yeah,
it was very interesting. Thank you so much for spending time with us. I think, I mean, the audience has been quiet. I think they're all blown away, and apart from the few who are crying in a corner because they won't be able to play with it for a while, because their job requires them to build something that just talks to a database. But you know, guys, it's so easy to play with some of these things. You can buy a Raspberry Pi for cheap, and you can do the most interesting things with it. The nice thing is that it's not like I remember back when I got a PC, and I tried direct memory addressing to improve the UI speed, and I would invariably make some calculation error, and I would overwrite the wrong piece of memory, and then everything froze. And I did actually discover that there was a small piece of memory that actually belonged to a part of the BIOS or something like that. So actually, it was the one machine I was working on was a Siemens machine, and I had to take it into them so that the guy showed me, no, you must take out the battery and let the Siemens battery run out, and then when you turn it up, it'll reset. Because I overwrote the CMOS in the process. And with a Pi is similar. You can mess it up, and you can just start clean, because you have a SD card with your image, and you start fresh, and you can play with these types of tools with those sound libraries or video manipulation. And get closer to just about any kind of hardware you want. And
Absolutely.
it's nice to play with. So if you want to do that kind of thing, that's a very good route to do it without fear of damaging the hardware that you're using, or making it unusable for a few days, which is typically something you can't
Working.
afford. Thank you for your time. Say hi to the guys at Azul. I know a few. Met Simon Ritter on a few occasions, and we've had some of the other people speak at Josie Jug as well. And maybe one day you can come and visit us in Joburg. We've got an annual conference that's usually in September, October. And come and join us. Come say hi.
Sure. It was a pleasure. Thank you very much for having me.
Thank you very much.
Take care. Thank you. Bye-bye.
Bye-bye.